Hello and welcome to Astronomy Daily, your essential guide to the latest news from across the cosmos. I'm Avery.
And I'm Anna. Coming up on today's episode, a diplomatic clash over space regulations between the US and the European Union. We'll revisit a 50-year-old scientific mistake that changed the course of Mars exploration.
Plus, we'll look at an unexpected dual crew situation aboard the Tiangong space station, check in on this week's launch schedule, and explore a new theory that sheds light on what happened less than a second after the Big Bang.
Let's begin with our top story. The United States government has formally pushed back against the European Union's proposed EU Space Act, calling its regulations potentially unfair and unwarranted.
That's right. The EU Space Act, introduced in June 2025, is designed to create a unified regulatory framework for Europe's space industry. It's built on three main pillars: safety, which involves tracking space objects and mitigating debris; resilience, focusing on cybersecurity and the continuity of space-based services; and sustainability, which aims to reduce environmental impact and simplify market access.
But in a formal response released on November 4th, the U.S. State and Commerce Departments, representing over 70 American space companies, warned that the act would impose unacceptable regulatory burdens. A primary concern is the addition of new environmental protection rules, which the U.S. argues would significantly drive up costs for operators.
The response also takes issue with provisions that seem to favor European operators. In what appears to be a thinly veiled defense of SpaceX's Starlink, the document claims the proposed rules unfairly target large telecommunications satellite constellations simply because of their size and success.
This is particularly evident in the section addressing satellite brightness. Starlink has faced criticism for the visual brightness of its satellites, and the U.S. response argues that a regulation limiting brightness would be impossible to implement and would disproportionately harm U.S. companies that operate at lower altitudes.
Interestingly, the U.S. document strikes a somewhat contradictory tone. It first suggests that space operations are too new and novel for strict regulation. But then it highlights that the U.S. already has a world-leading regulatory framework, having licensed over 1,000 launches. The core request is for the EU to recognize U.S. licensing to avoid burdensome duplication.
With the public consultation period now closed, the European Commission will review the feedback, including these pointed criticisms from the U.S. The draft may be revised before it is presented to the European Parliament and Council for potential adoption, setting the stage for a critical phase in transatlantic space policy.
From modern policy to a decades-old mistake, our next story looks at how a scientific error in the 1970s derailed the search for life on Mars. Nearly 50 years ago, NASA's Viking lander mission delivered a verdict that echoed for generations. Mars was lifeless.
This conclusion was based on the announcement from principal investigator Klaus Biemann that the landers had found no organic compounds on the Martian surface. While other life detection experiments on Viking returned ambiguous results, the absence of organics was seen as the final word. Without organic carbon, life as we know it couldn't exist.
But here's the critical mistake. Biemann's instrument had in fact detected organic compounds, specifically methyl chloride and methylene chloride. However, his team interpreted them as contaminants brought from Earth, even though the mechanism for that contamination was unclear.
The impact was immediate and profound. Believing Mars to be sterile, NASA shifted its focus. It took another 20 years before the next successful landing mission, Mars Pathfinder, touched down. For half a century, the story of a lifeless Mars has been accepted wisdom.
Now that consensus is finally changing. Thanks to the Curiosity and Perseverance rovers, we have multiple detections of various organic compounds, including the same chlorinated organics found by Viking. It's now clearer than ever that the original conclusion was wrong.
The scientific community is now calling to correct this long-standing mistake, and more importantly, to shed the negative mindset it created. The next step, many argue, is to launch a new robotic mission dedicated explicitly to the search for life on Mars, picking up where we should have been decades ago.
Next up, let's take a look at this week's launch roundup. It's a busy schedule featuring several high-profile missions that were scrubbed last week.
The second ever launch of Blue Origin's New Glenn, carrying the Mars-bound Escapade payload, is now scheduled for no earlier than Wednesday, November 12th. That's followed a day later by ULA Atlas V launching the Viasat 3 F2 satellite. Then on Friday, SpaceX has 2 Starlink missions on the manifest.
The week is expected to close out with a suborbital electron haste mission from Wallops and the Sentinel-6B mission. However, there's a significant factor affecting the schedule: an ongoing U.S. government shutdown.
Due to staffing shortages caused by the shutdown, the FAA issued an emergency notice banning launches during peak hours from 6 a.m. to 10 p.m. local time, starting Monday, November 10th. While a deal to end the shutdown is reportedly being worked out, missions like Transporter 15 have already been pushed to later in the month. Once the shutdown ends and staffing levels return to normal, the FAA is expected to lift the ban.
Now let's turn our attention to China's Tiangong space station, which is currently hosting an unprecedented dual crew operation after a suspected space debris impact delayed the return of the Shenzhou 20 astronauts.
That's right. The Shenzhou 20 crew was scheduled to return, but on November 5th, the China Manned Space Agency, or CMSA, postponed the landing, citing concerns over possible damage to their return capsule. As a result, crew commander Chen Dong and his 2 colleagues have remained aboard the station.
They have now been joined by the newly arrived 3-member Shenzhou 21 crew, creating a temporary 6% occupancy on Tiangong. The CMSA has activated its emergency plans, emphasizing that crew safety is the absolute top priority.
Both crews are reportedly conducting joint scientific experiments, leveraging the robust systems and ample supplies. Meanwhile, engineers on the ground are performing simulations and system tests on the Shenzhou 20 capsule, which remains docked to the station. No official return date has been announced, but reports suggest preparations are underway for a near-future return, using the original Shenzhou 20 spacecraft.
And finally, let's journey back to the very beginning of time. Cosmologists have a strong understanding of the universe's earliest moments, from the initial explosive inflation to the formation of the first atomic nuclei. But a period in between, lasting just fractions of a second, has remained the mystery.
A new study published in Physical Review D suggests this era was far more dynamic than previously thought. Researchers explored a scenario where, for a brief moment, dense clouds of particles temporarily overpowered radiation in the newborn cosmos. This shift would have created a matter-dominated era.
During this time, tiny ripples in density could have grown into massive halos of matter. While small by today's standards, these halos were massive enough to collapse under their own gravity, leading to a fascinating outcome: the creation of the universe's very first black holes.
These primordial black holes would have been extremely small, far less massive than the black holes we observe today. Some may have survived and could even constitute a part of the dark matter that shapes our universe. Others would have evaporated long ago through Hawking radiation.
The energy released by these evaporating black holes could have left fingerprints on the cosmos, potentially altering the formation of the first elements or the growth of large-scale structures. This work opens a new window into exploring the dark, hidden history of our universe's first second.
And that brings us to the end of today's episode. We covered the brewing regulatory tensions in space policy, corrected a 50-year-old misconception about Mars, and peered into the universe's earliest moments.
Thank you for joining us. From both of us here at Astronomy Daily, keep looking up.